Hi everyone, Assalamualaikum. So in this video, we are going to talk about hypothesis testing and effect sizes. This is our second video for the statistical inference series. Okay, we have already covered hypothesis testing in our previous classes, so this is just going to be a recap. You already know what hypothesis is, and you know that hypothesis testing is also known as a significant test, right? So in our previous video, if you can recall, we talked about estimations. We talked about estimations in the form of the point estimates as well as confidence interval. So now hypothesis test is just testing for a specific value of the parameter. Okay, so it is a process of rejecting or not rejecting a statement or a hypothesis that has been set up about the parameter. So you set it up, so you test against it. Okay, so here's an example of our hypothesis testing. So a consumer believes that the pH value of a drinking water is not close to the neutral value of 7. So the HO is the pH of drinking water is 7. Okay, if this is not true, he has three options. So he has three alternative hypotheses. The pH drinking water is not 7. The pH of the drinking water is more than 7. The pH of drinking water is less than 7. So then he chooses a level of significance, alpha, which is usually 0.05. So this is because we want to have 95% confidence level. So this is the allowable chance of making false conclusion, because the false conclusion is only 5%. Okay, we allow for 5% error. So next, he selects an appropriate statistical procedure to compute a single test statistics, or T. A decision rule is formulated based on the statistical procedure, and the underlying distribution most commonly used is the normal distribution. We have already talked about this earlier. The area from the curve from the center all the way to the right is 0.05. So is the area from the center all the way to the left. As the t value increases, the tail becomes smaller. So remember this. So let's take a look at the hypothesis testing just now. So the researcher anticipates that the pH value to be either too alkaline or too acidic. So this is known as a two-sided test. Okay, so this is a two-tail. If t is far from 0, the area under the curve will be less than 0.05. If reported significance value is less than 0.05, the null is rejected and alternative is therefore accept. So when you only have a single-sided, it's called the one-sided test. Okay, as the name implies. If the t is a large value, the area under the curve will be less than 0.05, hence the null will be rejected in favor of the alternative. Again, the pH drinking water is less than 0.7, is less than 7. One-sided test, if the t is large, okay, the area under the curve will be less than 0.05. Hence, null will also be rejected, and we shall favor the alternative hypothesis. So let's take a look at the probability curve here. So as you can see, in our example here, you have a one-tail, right-tail test where your alternative hypothesis is mean is actually more than the value that you predicted. The pH level of the water is actually more than 7. When you predict so, this is going to be your distribution. So the other one is the left-tail test. So this is when you predict the mean score is going to be less than 7. And this is your two-tail test. When you predict, it's not going to be 7. So we don't know if it's going to be more or less, but we just assume that it's not going to be 7. Okay. So generally, if the reported significance is less than 0.05, null is rejected. So this is how you report hypothesis. We fail to reject the null at the stated level of significance. Okay. We fail to reject the null. If the null is true, we fail to accept the alternative hypothesis. Okay, we cannot say that we accept the null since it was formulated in the intention to be rejected in the first place. We have already talked about the type 1, type 2 error and also power of the test, and we have, I guess we have already discussed on effect size in our last class. So I'm going to leave that to you to do your readings. I shall see you in our next slides. Thank you very much.